acid anhydride. An acid anhydride is made from two identical carboxylic acid molecules. State key difference between acid anhydride and acyl chlorides reacting with water, ammonia, alcohols, and primary amines. Before I carry on with that, let's just go through what it produces. Acyl chlorides react with water, producing carboxylic acid. Acyl chlorides react with ammonia, producing an amide. Acyl chlorides react with alcohol, producing an ester. Acyl chlorides react with primary amines, producing N substitute amide. So the key difference between acid anhydrides reacting with all of these, water, ammonia, alcohols, and primary amines, and acyl chlorides is that acid anhydride is made from two identical carboxylic acid molecules, and the reactions are less vigorous, and instead of HCl forming, you get carboxylic acid formed instead of HCl. Now let's go on to this nucleophilic addition elimination mechanism. So acyl chlorides, both chlorine and oxygen atoms draw electrons towards themselves. Chlorine and oxygen atoms draw electrons to themselves. Carbon has a slight positive charge, therefore it's going to be easily attacked by nucleophiles. So before I even carry on, with water, ammonia, and your primary amines, because this is already the alcohol I'm showing the mechanism for, but it can happen with any of these. So I guess you should practice it. But in H2O with water, the oxygen is going to have lone pair of electrons. With ammonia, the nitrogen is going to have lone pair of electrons. With primary amines, it's also going to be the nitrogen with lone pair of electrons. But just showing you guys where the lone pair of electrons are on the specific parts. So in this case, alcohol, two lone pairs of electrons on oxygen, nucleophile, attack partial positive carbon, transfer electrons to oxygen. You form this. Oxygen's lone pair of electrons negative charge, and it wants to reform the double bond. In order to reform the double bond, CCl bond must break, and oxygen is now positive because it's donated all those electrons. So you form this double bond O here, Cl minus leaves with lone pair of electrons. Oxygen is now positive. Oxygen has positive charge, yes, CH3H. Cl minus bonds with H plus, your HCl, and what happens is from middle of OH to the oxygen. So now you're left with this H3CC double bond OCH3. So the H is just left with the OH and just bonded with Cl.